So students, now we'll study about the properties of charge. So what we have discussed so far is about the how we can initiate charges on the conductor, and now properties of charges include again the same thing, that there are two types of charges we have discussed earlier also, the positive charge and the negative charge. Now the thing is that we need to understand what are the important properties of the charges, because there are many important properties which we need to understand before going into the detail. Now let us take the very important property of the charge, that is the additivity of the electric charge. That means, what is additivity? Additivity means we can very simply add the electric charge just like a real numbers. Like that means it is just like an algebraic sum of the charges. How it can be added? Suppose we give certain charge to an object. Suppose we have object A, we have object B, we have object C. Object A has suppose plus 3q charge, and object B has minus 4q charge, and the object C has plus 5q charge. Now if we need to add the charges together, the simple mathematics is involved, which is the algebraic sum of these charges. We are going to add them just like mathematics. We can add them. So plus 3q minus 4q and plus 5q will give you plus 4q. That means the total charge of the system will be plus 4q. So this is one of the simplest method to understand what is the additivity process in the charge case. Suppose you come across an object and it is showing that the total value of the charge comes out as 0, like it is 0 here. So what does it indicate? What does it implicate? It implicates that the total charge sum is coming out to 0. That means object is neutral at all. It does not have any charge. So if you get a problem in which you will get some bodies or which certain charges are there, and you need to find out the total sum of the charges, so you need to just add them. Suppose we have a body which has plus 2 charge and plus 3 charge, like this. Suppose it has, suppose I just take like example in this. If a body has two different charges, there is no negative charge in the body. Like it has plus 2q charge and plus 3q charge. What will be the total sum of the charges? It will be plus 5q. Very simple. So you have to just add them like a numbers. In mathematics you have to add. This is one of the important properties, and it is very important in calculating the total charge on the objects. Now this is that property which tells you how we can find out different charges on different bodies. Suppose we have 2-3 bodies together, they have certain charges, and you need to add them. So you have to just add them mathematically and you get the answer. The second important property which we are going to take right now is the invariance of electric charge. See, the term invariance means charges are having nothing to do with the frame of reference. We are not concerned with the selection of frame of reference. That means if a body is moving or a body is at rest, maybe the observer is moving or is at rest, it is nothing to do with the charges at all. Charges will remain same. It will not going to change. That is what is called as the invariance means. Invariance means the thing that cannot be changed remains unchanged. So in our case, we see that the electric charges are free from the selection of frame of reference. It does not depend on the speed or maybe the motion of the object or observer. What does it mean? It means that suppose we have a charge which is at rest and we have a charge which is at motion. Both are same. They are not going to vary. That means the charges at rest will remain at the charges in motion. Both are just same. So this is one of the most important property of the charges, because we need to understand sometimes we come across the problems in which we get the body is moving and has certain charge, suppose plus q, and it is moving in certain direction, and another body is at rest. Now, is there any change in the charges of these two bodies? What should be your answer? Your answer should be, because we know the properties of the invariance of electric charge, we can simply find out them easily, because both are same. They are same, whether it is at rest or it is at motion. So there is no change in the charge, either in motion or in the rest position. And I give you a simple application of this. We must have heard about certain things that if the body is moving with the velocity of light, we all know about the velocity of light, which is denoted by c, 3 into 10 to the power 8 meter per second. We all know this thing. That means if we have a body which is moving with the approachable velocity of light, that means in that condition we know that the mass of the body becomes very high. And why it is very high? Because the relativity comes into picture. Though it is not directly related to this topic, but I will tell you in short how it is going to affect the mass. Because see, we know that what is mass? Mass we know that is related to the relation m equals to m naught upon under root 1 minus v square upon c square. Now this is the relation for the mass in case of relativity. But suppose our mass increases in a case when your velocity approaches to c. What will happen to the mass in this relation? You see that the moment we put v equals to c, this relation will give you 0. That means your mass is approaching towards infinity. That means your mass will going to increase. This comes from the relativity. That means what we are saying, in particular case of relativity, the mass of the particle becomes very high when the velocity is approachable to the velocity of light, which is v equals to c. So that means in that condition our mass will not vary, but again the charge will not vary. The charge will remain same. Even then the mass is varying, but the charge will remain same. You can see this thing. It will not going to vary, it will remain constant. So that is one of the most important point that is coming under the heading invariance of electric charge. Now suppose someone asks you what other properties of their charge other than this relativity that comes from the ratio of charge to mass. Suppose we talk about the ratio Q by M. What is Q by M? Q by M means that is the ratio of charge. Q is charge, M is the mass. So in that particular case also we see that if in case of relativity if we talk in terms of relativity, then the mass will definitely going to increase. The ratio of this is known as the specific charge. What we call that ratio? We call the ratio of Q by M as the specific charge. That means specific charge tells you about the ratio of charge to mass. And how it is going to increase? It will increase only when the mass is pretty high. And when it can be high? It can be high in case of relativity. So suppose we find out certain things in case of relativity, we always found that the specific charge will going to decrease. Why is it going to decrease? It will decrease because of the reason we know that if I increase the mass, just see this relation, Q by M is the specific charge. So how it is going to increase? I increase the velocity. I increase the velocity to approachable velocity of the light. Then this mass will increase. The moment this mass will increase, this ratio will decrease. This ratio will decrease. That means specific charge will also decrease in the case the mass is approachable to the velocity of light, and in that condition your specific charge will always decreases. But as far as your charge is concerned, the charge will remain constant. So these are certain points which are very important to understand in terms of invariance of electric charge. These are some of the properties which are very important to understand before getting into the electric field topic. Because without understanding the relation of the charge at rest and charge at motion, you cannot find out the many other relation in electric field. So you have to understand once again that when we want to add the charges, they are simply added just like a algebraic sum. If their charges are known to you, you just add them like algebraic sum. We add in the case of numbers, plus q minus q plus q, again it will give you the q. That means simple addition. And apart from that, a very important topic which is invariance of electric charge, that is the most important topic, because here we need to understand charge does not change. Even the body is moving or the body is at rest, charge remains same. But it can affected by the body which is moving in the relativity terms. That means velocity is approachable to the velocity of light. In that condition, your mass will going to vary. The mass will vary again, but the charge will not change, because that kind of confusion comes in the mind of the students when they take some problems. Because when you attempt the problem, it's been written the body is moving with a certain velocity v, which is approachable to velocity of light. Suppose they give you that v is nearly equals to 0.9 c. So can you say this velocity is very low? No, it's very high. It's almost approachable to the velocity of light. In that particular condition, you need to apply the relativity terms, and you find out that the mass will definitely going to increase. Okay. In that condition, you need to understand these topics in detail. Now we understand something more than that what other properties of charge is there which makes it more important. That third property we are coming to is the conservation of electric charge. So what is you mean by the conservation of electric charge? See, conservation itself means we are just trying to find out that something is going to remain conserved, it will not going to change. Suppose I talk about a simple term, if I have a total charge on isolated system, that total charge remain conserved, it will not going to change. We all know a very simple conservation law of energy. What does it say? Energy neither created nor destroyed, it just transferred. Same thing is applicable in the case of charge also. how charges also can either be created, not destroyed, but it can only be just transferred. So it is almost similar to the conservation law of energy. That means it is one of the important topic here to understand how we can find out the conservation of electric charge, because we know that the total charge of the system should always be conserved. Whether you are talking about system A or system B, it cannot change. But you have to understand, we are not neither creating the charge, we are not neither destroying the charge, but we are just making it conserved, or in terms of transformation part is done. Now a very simple example to understand this topic further. Suppose we take the example of electron and positron. We all have heard about electron. Electron means we talk about E minus, that is called as electron. And when this electron is combined with the antiparticle, suppose electron is having minus sign, antiparticle is having the plus sign. So that is called as the positron. Now positron and electron, when they combine together, they give certain radiation that is called as the gamma rays. That is called as the gamma rays, which has the energy 1.02 MeV. Now just try to understand. We have taken certain example of the electron and its antiparticle. This is electron and this is antiparticle is positron. When they combine together, the important thing is that the total charge when combined together gives you something which is chargeless. Gamma rays are the electromagnetic radiation. They are chargeless. They don't have any charge. But they give you radiations of certain energy 1.02 MeV. That means this is also showing you that total charge of system can be zero, but as a whole it is conserved. I take you a simple example again. Now we have seen in the previous lectures also that we have the glass rod and we have something we can rub it with the cloth. Now just tell me that suppose we have a glass rod and we are rubbing it with the silk cloth. Before rubbing, do you think that both have certain charges? There is no charges on the glass rod on silk cloth before rubbing. Both initially were uncharged. The moment they were rubbed together, the glass rod acquired certain charge, which we discussed was the positive one, and the silk cloth has taken the charge minus charge. That means as a whole, the total charge of the system, if you see that, what should be the total charge of the system? It should be zero, because the plus charge of the glass rod and the minus charge of the silk cloth will add together and will give you the total zero. That means the total charge of the system is zero in this system. So this is also very interesting case to understand, like how we can understand about the conservation of electric charge. It can be in many examples we can understand. We have taken the example of the electromagnetic radiations. Similarly, this term is called as the pair production. What is pair production? Pair production means if we just take the gamma rays, it will dissociate to give you electron and positron. Even in that condition also, we understand that certain energies was there which dissociate in the form of electron and positron. Or in the other case, we can say these two particles and combine together give you something which is non-charging or chargeless, that is the gamma radiation. So this is a very beautiful example of understanding the conservation of electric charge. We will take the next topic in which we will study more about this area and how we can use it in the further direction. That I will tell you in the next one. So students, we have just discussed more of the properties now. As we discussed earlier also, some of the properties in which we show that how we can show the conservation of charge. Now let's take the example of some radioactive decay. Now I have shown here, this you all know is the uranium 92U38, and when this will give you on decay the byproduct as the thorium and alpha particle, that is 2He4, and you see that before the decay, the initial charge was 92E, that means electron, and after the decay we see that the total charge is 90 plus 2, that means 90 plus 2, that is 92. That means charge before the reaction and after the reaction of decay remains same. That is what is known as the conservation of the charge. So we can see it very clearly in the equation now. Suppose we need to understand, apart from the radioactive decay, where we can see that the conservation of charge occurs. So we can take some more simple example. Now I have taken the example of simple 7 and 14, that is for nitrogen. This is the atomic number, this is the mass number. We know that the atomic number of nitrogen is 7, mass number is 14. Then when it is combined with the alpha particle, the charge is 2 here and the charge is 7 here. Now we can see that when the equation occurs, we see that after the equation, in the right side we get the product as 9F18. That means it's for the fluorine and 9 is the atomic number. So now you can see here itself then 7 plus 2 gives you 9, and here also you can see the 9 value. Also this equation can be further taken up and get the byproduct as 8 oxygen 17, where 8 is the atomic number of the oxygen and then 1H1. So again you can see that 8 plus 1 again is 9. That means we can see very clearly over here that the conservation of charge occurs in all the equations, in all the areas, apart from that what we have discussed in the radiative decay. In all normal equation also we can see that the charge before the equation and after the equation we can see the same values coming, like 7 electron plus 2 electron gives you 9 electrons, whether the equation started with the nitrogen or it start with the fluorine or something else. That means it's very clear now that the conservation of charge applicates in all the areas starting from any of the point. Now we take that how we can take up some more properties of the charge apart from the conservation. Now we have discussed conservation of charge in detail now. I think you know clear about each and every topic of what conservation of charge means. That we have shown you very clearly that charge does not get destroyed, cannot be created, it just can be transferred. Whatever charge was there initially being transferred to the byproducts. That means that is called conservation now. Now we take the very important topic of the charge, that is known as the quantization of the charge. Now what is quantization of the charge means? See, this term quantization itself is very important. Let me tell you why it is important, because quantization means that if we want to exchange certain physical quantity, that physical quantity can be exchanged only as discrete. Now what does the discrete means? That means something which is not continuous. A minimum amount of energy that can be exchanged, minimum amount of exchange can be done in the quantity is known as the basically quantization. That exchange is called as quantization, and the minimum amount of exchange that can be done is said to be quantum. Now quantum is the minimum lowest unit that can be exchanged in the physical quantity, and that is all about the charge also. That means if you want to see the exchange of any physical quantity, that has to be first of all discrete. It cannot be continuous. Discrete means when something is not taken continuously, it's just in the part of the small segments. So this is called discrete, if I have to say, and this is called continuous. This is a continuous process, you can see, and this is a discrete process. Discrete means when it is being done in the small segments. So we can see that the minimum value that can be exchanged is known as the quantum. Like if you have to find out what is the minimum amount of energy or minimum amount of value that can be exchanged in physical quantity, that is all about the quantum we are talking here now. Now how it is being done? Now how you can say that this amount of energy or this amount of charge can be quantized? It has to be done in terms of certain values. That value is known as basically quantum. Now let me tell you what quantum means here. See, suppose I have to exchange certain electrons, that can be done. Maybe in some of the body we need to exchange certain charge from one body to another body. That can be only done in terms of whole number. That means it can be transferred, it can be changed from one body to another body, but it has to be in the whole number. It cannot be in the fragments, it cannot be in the fractions. Like suppose I tell you how it can be transferred. Suppose I tell you in case of any of the object, you have certain charge. Now this charge has to be exchanged. That governs by the relation Q equals to plus minus NE. Plus minus NE means N means the number. That number can only be the whole number. Suppose I need to say that this much charge being transferred to the other body, and how much charge can be transferred. So that means your Q can be either plus 1E, it can be plus 2E minus E, but it cannot be 1.2E, not possible, 1.6E, not possible. That means it cannot be transferred in terms of fractions or some decimal points. So that means that is very clear now. Quantization means can be exchange that can be done between the two physical quantity, and that exchange has to be in a certain whole number point, and the whole number has to be something like this, what we have shown here, that it can be Q equals to plus minus NE. That means N is the number, it is the whole number. It can be have value 1, 2, 3 maybe, but cannot have the value 1.2, 1.3, 1.5 like that. That means that is one of the important properties of the charge, that how we can understand the quantization of charge. Like suppose we need to find out, we have certain body A, we have certain body B, and these body have, suppose, transferred the charge from this body to this body, and that transfer can be in terms of certain value. So you can say that this much amount of charge being transferred from body A to body B, it can be either plus 2E minus E, or it can be plus minus 4E, but it cannot be like plus minus 1.2E. It's not possible, or plus minus 4.2E, it's not possible. So that is very clear now, that we have to understand very clearly, if we want to understand how the exchange of charge can be done, how it can be possible in case of the charges. So we need to find out whether we are doing it properly or not, even because there may be some numericals where you get the values and you have to solve that numerical. Then you have to realize this formula, that how we can use this formula for solving certain numericals. They can ask you how many number of electrons are there in that particular body. When the charge is this, charge of electron is this, then you need to find out the small value n. I'll get you in the one of the numerical after this. So now let's understand what actually is important in this topic. Suppose we know the charge is there, and it has to be in the whole number multiple of the charge. Now, which is the smallest unit of charge? The smallest unit means the smallest value. The minimum value of charge is, we all know, should be 1.6 10 to the power minus 619 coulomb. Okay, that means this value is very important for you. That is a key value. It is the minimum value of the charge. Charge cannot have value below than this value. This is the minimum value of the charge. You have to understand it very carefully. Now, charge is also related to the mass. We all know that charge has some relation to the mass, but it is always related to mass. Charge does not exist without the mass. That's very important, I'm telling you. This word, it is very important. Charge does not exist without mass. But can you say this thing, opposite is possible? Yes, opposite is possible. You can have certain mass without the charge. You can ask me where you have seen this thing. Yes, there are many examples. I'm giving a simple example of photon. A photon is a massless and chargeless because it does not have any charge. It does not have any mass, even then it exists. Similarly, you have one more simple example. You have heard about the neutron. You must have heard about the neutron. What charge neutron have? Does it have any charge? Any charge it has? No, it has no charge. That means it is chargeless. When it is chargeless, that means still it has mass. So we cannot say it's vice versa. Suppose charge is related to mass, it does not mean that mass is also related to charge. There may be body which has certain mass, but they may not have charge. But it is not applicable in the case that charge is also related to mass, so mass is also related to charge. No, that's not possible. So these are some of the examples where we can see that they may have the mass, but they don't have any charge as such. So this is a very important example. You have to understand. The example I have given you for the neutron and the photons. Now the thing is that, suppose someone asks you that whether charge creates or it initiates some electric field. Yeah, it initiates electric field. We know that if the charge is at rest, suppose the charge is at rest, whether it will going to create an electric field or not. Yes, it will going to create an electric field, because we know the relation that will come in the later topics also. F equals to QE, that is force equals to Q time E, where Q is the charge and E is the electric field. Now the point is that whether the charge is at rest, it can produce electric field. Yes, it can produce electric field. But what about the charges in motion? Suppose someone will ask you, if the charge is moving around, it's in motion, what kind of fields will be there developed? It will have two fields then. Apart from electric field, there is also a magnetic field in this, that is called as the E and B. That is electric field and magnetic field. So you have to understand very carefully, if you have certain charges with you, someone may ask you, the charge is at rest, what kind of field will be developed in this condition? Your answer should be electric field. Suppose they ask you, the charge is now in motion. Now what kind of fields will be generated here? You have to tell them it is electric field as well as magnetic field. And we know that both are basically mutually perpendicular to each other if we talk in terms of the electromagnetic waves. Now the question arises, what happens if the charge is accelerated? There is a difference. I am telling you three things together. The first thing I said, the charge is at rest. The second thing I said, the charge is in motion. The third thing I am saying is the charge is accelerated motion. When you say something is accelerated motion, apart from electric and magnetic field, something more is liberated. That is what? That is known as the electromagnetic radiations. That means if the charge is in motion and that motion is accelerated motion, you will get to see the electromagnetic radiations. So this is very important aspect you have to understand in this particular topic, that if you talk about the quantization of charge, you need to understand how much things are just related with the charge. not only mass, there are certain more things that is related to the charge. So we have understood very clearly here, if the charge is in motion, we can get different aspects. Now I ask you simple thing about here. Suppose we know that the minimum value of charge is 1.6 × 10⁻19 coulomb, and that is what is also being confirmed by the Millikan's also. Millikan has given one of the experiment in which he confirmed about the charge is related to mass. That's very clear from the experiment. Now the question arises, suppose someone may ask you that, okay, now just find out how many electrons are emitted on charging a metallic ball with 1 coulomb positive charge. The simple question comes in your mind. Okay, this can be a very simple question. How many electrons are emitted on charging a metallic ball with 1 coulomb positive charge? So what should be the approach of solving the question? The question is very clear, not confused. Should be doing it directly in this particular formula can be applied here directly. So I will take the formula Q equals to Ne first in this question, and then we are going to solve it. You have been asked about the number of electrons. How many electrons you have been asked? So that means you have been asked about the N. So what is given to you? Q is given to you as 1 coulomb. You have been given, what else you have given? E is the charge. You all know that is 1.6 × 10⁻19 coulomb. And you are asking about the N here. That means what should the formula? N equals to your Q upon E. There Q is very clearly given to you 1 upon 1.6 × 10⁻19 coulomb. So that means we need to solve it further, and we should get some relation and the values. It should be something around numbers that may be 1 upon 1.6 10⁻+19. Okay, and that always in numbers. It will not be in the any unit will not be there, because it shows you some number. The value should be around 6.25 10⁻18 electrons, number of electrons. So that has to be very clearly understood. So this is how you can approach some of the numericals. I've just divided properly and I get the answer like this. So when you're doing something like this, you need to understand that this is how we have to find out certain values. Okay, now let me take it in detail now. Suppose someone is asking you about how we can find out charge in different bodies. So again you have to use this formula, because we know that there is a simple relation between the transfer of charge from one body to another body. It always occurs, or exchange of is always done by the relation Q equals to Ne. It can be plus minus Ne because the values may be changed. You can have different values, but the procedure should be same, and we can solve it further to get the details over here. So what we have studied so far, I'll just recapitulate the details once again for you. So we have discussed over here the important properties of the charges. We have taken the properties which are very related to the invariance of the charge, which was related to the one of the important aspect of the conservation of the charge. So these are the important areas which we have done over here, and we have found out that charges can be very important for studies related to electric field. Without understanding the charges, we cannot think about the electric field in details. So I hope that you have understood these topics very clearly, and if something is left in that, we are going to take in the next topic, which we are going to take in the next class after that.